Alright guys, so I have already pre-written the notes, that way you don't have to hear the pen clanking every time. Okay, so please still listen to kind of like the explanation that I'm gonna say, um, because I don't know, I feel like it might help if what I'm writing doesn't help. I try to elaborate a little bit more of what I wrote. So a two-column proof is a proof in which the steps are written in the left column and the corresponding reasons are written on the right column. So this is very similar to what a flow chart is. The flow chart still has the same steps, but it's kind of a little bit not as organized. Okay, so number 8, how does the two-column proof relate to the flowchart proof? Each step of the flowchart proof is represented in a two-column proof, but with reasons on the right and statements on the left. Okay. Also, if you ever see QED, that basically means that that's the completion of your proof. All right, number 9, Khalil insists the angle in figure 1 is larger than the angle in figure 2. Roy disagrees and insists that both angles are the same size. So as you can tell, they're both right angles. However, the ray, remember that a ray looks like something like this. This is a ray, right? So you have two rays here. The only difference here is that the rays are one of them is longer and one of them appears to be shorter. However, you have arrows on both of these. That means that just because on the figure they cut it short doesn't mean that that's where it stops. It goes on forever because it has arrows on both ends. Okay, so who is correct? Justify your reasoning. I hope you guessed it right. Roy is correct. The ray length does not affect angle measure. Okay. I think that one's pretty self-explanatory. Moving on. One of Euclid's first 5 postulates relates to the right angles. The right angle congruence postulate states that all right angles are congruent. While this statement is accepted without proof, definitions can be used to prove it. So this is what they give us. Given angle ACD and angle BCD are right angles, we have to prove that angle ACD is congruent to angle BCD. So we're going to complete the flowchart to prove this, and they give us the reasons right here on the left hand side. So all of these are the reasons. Okay, we just have to put them in order. So angle, let me go ahead and get my pointer. Angle ACD is a right angle. That's what's given to us, right, from right here. They also give us that BCD is also a right angle. So BCD is a right angle. That's another given from right here. Angle ACD is equal to 90 degrees. That's the definition of right angles, right? Similarly, angle BCD is equal to 90 degrees, again, by the definition of right angles. So you can go ahead and cross this one off. Now, angle ACD, the measurement of angle ACD is equal to the measurement of angle BCD. Since they're both 90, then they're equal to each other, right? And that is because of the transitive property. Remember, the transitive property states that two things, or like, for example, 5 is equal to 5. It's pretty obvious. 3 is equal to 3. Same thing here. ACD is 90 degrees and BCD is 90 degrees, so they're equal to each other, right? And then finally, this is what we wanted to prove. This is our conclusion. Angle ACD is congruent to angle BCD by the definition of congruent angles. Okay, so I thought that was pretty easy. Why is the order of the steps important in a flowchart or two-column proof? So although you can have many different ways of proving something, I could have rearranged this a little bit differently, and I could have still arrived to the same conclusion. However, you need to make sure that whenever you are rearranging things, there's plenty of ways to prove something, right? But it needs to logically follow. So that's what I wrote here. Each step needs to build from the prior step before arriving to conclusion in a logical manner. Okay. Considering what you know about angles, you might conjecture that if two angles are supplements of the same angle or of congruent angles, then the angles are congruent. Let's prove that this conjecture is true. So use this diagram to write the given. And let me get my pointer again. Statements for the congruent supplement theorem. The proof statement is provided. So remember, whenever you see like a little arc right here on both sides, that's telling you that angle 2 is congruent to angle 4. Okay? So what is it that they tell us here? Angle 1 is supplementary. This angle is supplementary. They also tell me that angle 3 is supplementary. Another thing that they tell me is that this angle 2 right here is congruent to angle 4, right? Therefore, angle 1 is also congruent. This angle right here is also congruent to angle 3. Because what does it mean for it to be supplementary? It means that it has to be 180 degrees. So angle 1 and angle 2 together has to be 180 degrees. So if this angle 2 is congruent to this angle 4, then angle 3 plus angle 4 and angle 2 plus angle 1 must also be 180 degrees. All right. Cut out and use the statements and the reasons located at the end of a lesson to complete the flow chart to prove the conjecture. So for this one, this is going to be, the cutout is on page 393. You're more than welcome to cut it out and paste it. If you don't feel like doing that, or if you don't have your book, just go ahead and write it out like how I did. So angle 1 is supplementary to angle 2. That is what's given to us, right? From that, we can say, well, what does it mean for it to be supplementary? Supplementary means that the two angles added together is 180 degrees, right? That's by the definition of supplementary. That's how I got that. Now here, similarly here, angle 3 is supplementary to angle 4. So whenever I add the two angle measures, I get 180, again, by the definition of supplementary angles. Angle 2 is congruent to angle 4. That's what's given to us. And from that, we know that the measurement of angle 2 is equal to the measurement of angle 4 by the definition of congruent angles. So if two angles are congruent, then the measurements must be equal to each other. Okay, so let me elaborate a little bit on that. So for example, let's say I have, if I have that, they say that angle 2 is congruent to angle 4, right? So that means that if this angle 2 is, I don't know, 80 degrees, then this angle 4 is 80 degrees, so that they are equal to each other. The measurements of both of them are equal to each other. Okay, that's a little example for that. From then, we can go ahead and get that the measurement of angle 1 plus the measurement of angle 2 is equal to the measurement of angle 3 plus the measurement of angle 4. And the reason for that is, let me get my pointer again. So if you have the measurement of angle 1 plus the measurement of angle 2, then that is equal to the measurement of angle 3 plus the measurement of angle 4, okay? Because of this right here. We would not be able to get this without these two right here. We've established that they're supplementary, that they're 180 that they are 180 degrees, okay? And you can just substitute. All right, so moving on. The last thing here is that the measurement of angle 1 is equal to the measurement of angle 3 by the subtraction property of equality. So let me explain how they got that. So right here, we had the measurement of angle 1 plus the measurement of angle 2 is equal to the measurement of angle 3 plus the measurement of angle 4, right? We are getting that the measurement of angle 1 is equal to the measurement of angle 3. Well, we know from right here, let me get the pointer again. we know from right here, the definition of congruent angles, that the measurement of angle 2 is equal to the measurement of angle 4. So angle 2 and angle 4 are exactly the same thing. They're equal to each other. So if I subtract the measurement of angle 2 here, that goes away. And if I subtract the measurement of angle 2, this goes away as well. Why? Because they're equal to each other. So I'm allowed to do that. And that is called the subtraction property of equality. So if you subtract two things that are equal to each other, if you subtract it on one side, you have to subtract it on the other side. And then that leaves you with just the measurement of angle 1 is equal to the measurement of angle 3. And I kind of wrote over it. But then that leads us to what we wanted to prove, that angle 1 is congruent to angle 3 by the definition of congruent angles. Because again, whenever two angles are congruent, they are also equal to each other, and vice versa. If they're equal to each other, then congruent to each other. So to elaborate just a little bit more on this, if I give you another example, like we already did this in class, subtraction property of equality, but algebraically, if I were to have 5x is equal to 2x. So I'm saying that 5x is equal to 2x, right? So let me back up actually. Let me erase this. I didn't need to write that. So if I have that 5x is equal to 2x, and I do minus 3 here, then I have to do minus 3 here. Okay, because that is the subtraction property of equality. I have to be equal on both sides. If I subtract something on one side, I have to do it on the other side. Same thing with angle measures. And I feel like a lot of you guys might be a little bit confused as to why if I'm doing the measurement of angle 2 here, why is it that I'm able to do it here again? The reason why is because these two angles are congruent to each other from right here. And remember, if they're congruent, then they're equal to each other, right? All right, so hopefully that was a good explanation. Page 387, whenever you get to class, it's going to be your warm-up. So that's going to help. Make sure that you wrote down these notes, because this page right here, 386, is going to help you answer page 387 that you're going to have as a warm-up next time I see you. All right, guys, have a good day.